Welcome to Hexagon Geospatial e-training. Our topic, flexible ways to visualize a digital elevation model using the ERDAS IMAGINE Image Chain. In this module, we'll look at the relief mode and see how it can be used to help interpret elevation or other surface type information. I'll begin with a DEM displayed in the viewer using the standard grayscale display. Using this display mode, we can see elevation represented with various shades of gray. Higher elevation will be lighter in color, and lower elevation will be darker. We can use the image chain to further enhance this data, making it easier to extract and interpret information. Rather than using the spatial modeler to preview the data, I'll open the data directly using the image chain. To do this, I'll click on the File tab and select Open Raster as Image Chain. From the file chooser, I'll select the elevation data I want to visualize and click OK. Since this image has header information that identifies the data as elevation, the image chain defaults to the relief mode with a sun angle shaded representation of the elevation information. This representation is already easier to interpret than the original grayscale rendering of the data height values. For example, fine detail in the valleys is easier to see. On the Preview Relief tab, we can control the sun angle, the vertical exaggeration, and other parameters of the relief shading effect. On the Sun Shading tool, the small circle represents the sun, N defines the direction, and the rings define the height off the horizon. The outer rings are closer to the horizon, while the center places the sun more directly overhead. I can also modify the vertical exaggeration. Using the arrows next to the scale value, I can increase and decrease the scale. If I zoom out to the full extent of this data set, it's easy to see one of the shortcomings of the plain relief shaded representation. Relief shading highlights local changes in relief very effectively, but overall trends are normalized out. For example, it's hard to tell if the area to the northeast is at a similar altitude to the area at the southwest. Both show lots of local detail, but the relative difference in altitude is lost through the relief shading effect. To regain this information, I can turn on the Use Color option in the Preview Relief tab. This forms a merge of the relief shading with the original elevation values. I immediately regain the ability to see the overall difference in elevation. However, detail has been lost in the northeast corner where elevations are lower. Here, the grayscale information is darker with little contrast. Again, I can adjust the image parameters in real time to bring out the detail by shifting from a grayscale merge to using a color ramp of the elevation data. To do this, I'll click on the Color Table button to bring up the gallery of predefined color ramps. Hovering the mouse over a color ramp chip in the gallery will preview the effects of that ramp in the 2D view. I'll move the mouse around until I find a ramp which provides the desired effect, such as the aptly named elevation ramp. Click on the chip to apply it. I now have the results of the flexible image chain for displaying surface-based data. The shaded relief displays fine detail, while the overall differences in elevation are still retained through the color ramp. Since I've used the image chain, I can still manipulate its display parameters, such as the sun illumination angle, in real time and pan or zoom and rotate the data. Thank you for watching this Hexagon Geospatial e-training module, visualizing elevation data with the ERDAS IMAGINE Image Chain. For more e-training, visit hexagongeospatial.com/e-training.